Hello, this is the ARMS, Automated Asset Rfid Management System. I'm the team lead, my name is Alex. This is Nick, he was responsible for most of the SQL and database and website management. And then this is Devaj, he was responsible for a lot of the hardware as well as the interconnection and the purchasing, things like that. So this project started, it was sponsored by GE, General Dynamics Mission Systems to be specific. I interned there, I've been interning there for the past few years, and one of my summers interning there, I was tasked with helping find some government items because they were doing an audit. They would like to know where their items are. So after beginning this task, I was given a list of where things were. And after asking how recent this was, they said, oh yeah, that was from last summer. We had another intern do it. And these are items in a rack, so they definitely weren't there. So what we did is we spent the next few weeks tracking these things down on paper and clipboards, which is the way things are done typically in the industry. And after weeks and weeks of going to people and asking custodians of items where they were, and hearing the phrase, which is very popular apparently among the industry, is, oh, it must have grown legs and walked away. Figured if we put trackers on them, some type of tracker, some way to detect them automatically, these legs would either disappear or we could at least watch them walk away. So our project is an RFID-based tracking system. Purpose is to automate the movement, watching the movement of items through a lab. Because these items don't leave the warehouse permanently. They're typically always in the lab for the life of the product, pretty much. So being able to go and find an item you need to test with in the blink of an eye is extremely useful for the testing facility because you need to know where something is, and trying to find that item takes time away from testing. And so also it allows for people like the government who have blended items to companies, it allows them to come in and say, hi, we just would like to know where our things are. The company can then go press a button and then just say, they're all right here, we can verify right now, this database shows it. Instead of having to spend weeks of engineer time and engineer hours, especially, to do these things, which could take seconds with an automated system. So the design uses passive RF stickers because that way no sticker would have to be charged. The way these stickers work is they have to be, or they don't have to be charged at all. They're completely passive, they run off the power of the antennas. So they're near field, the antennas will be placed in racks, and that way, if it's placed in a rack, you know where it is, or at a doorway, if it passes through a doorway, you know that it passed through a doorway at a certain point in time. That's valuable because that allows you to not only know where things are, but where things have gone to. So if something leaves the building, you know when it left the building. And also, we decided to connect this to a network and then have a database to track and manage all these things. And then we also decided to create a web server as an easy way for the end user to actually access this information and sort it and actually use it to their benefit. And also, at the very end, we decided to add a functionality for notifications. So if you want to know whenever a database is updated or whenever something leaves a location, you would like to be notified. Like if you've just gone home for the day and you have an item that's very important and it leaves its position without your knowledge, you'd like to be notified. Well, with paper and pencil, you can't do that, obviously. So our system, with an automated design, allows us to get not only email, but text message notifications whenever something changes, which is very useful. And so I'm going to move it over to Devaj, who's going to talk about the customer requirements, the constraints, and the type of protocols we use to achieve this.
So starting off, we created requirements, and with those requirements, they came with constraints and standards. So some of the constraints we used were the FCC communication, and we also used General Dynamics internal policy to make sure everything was up to their standards. And then for standards on the actual system, we also used Alien Protocol, which was the name of the reader that we used. We used TCP/IP, SQL, among other things for the whole system as well. Once we figured out constraints and standards, we turned those into customer requirements, and some of those are system shall be detected entry or exit of a door, system shall be detected in a rack, and other things like that from the proposal that Alex had for the system. And then from these requirements, we created engineering requirements. That way we have a hard yes or no if we pass them, and they also were quantified, so we had a number for all of the requirements that were there as well. So this is just a list of all the requirements that we had. I'm not going to go through all of them because they're somewhat long. One of the things that happened was along the way we had to change one of the requirements. So the initial requirement was that a tag needed to be 2 inches by ½ an inch. But we found out that the tags that we were using were 2.75 inches by 0.75 inches. So what we did was we talked to our customer and we got it changed and it was approved by our customer. I'm going to pass it off to Nick.
So as Alex mentioned earlier, our first subsystem in the overall system is the Rfid Reader, and detects assets based on what assets have our tags on them. The reader generates a text file, which we wrote a Java program to take the data from that text file and update the database with all of the asset information based on RFID tag. And then the end user system, which is the website where you can look at all of the changed and updated data for all of the assets. There was multiple approaches that we could have taken for this project. There was 2 main options for the reader manufacturer, and there was 2 main options for the user interface. We chose the Alien Reader over the Thing Magic because the Alien Reader was more documented than the Thing Magic was. And on the Thing Magic website, the company stated that the Thing Magic F6 should no longer be used for future projects. So for the user interface, there was 2 main options, as I said. There was the website, and there's also a downloadable application. We chose the website for scalability. We were concerned with time with making 2 different applications, for example, Mac and Windows. And with a website, you just need a link and you can automatically access the user interface.
So these are some of the main points of our technical design. With the setup, obviously we had the RFID tags, we needed a reader, and we also needed antennas for all the racks and the door. And then we also created a data flow to help us better understand the way it works. So from the readers, we get a tag, and then that's sent to the Java file, as Nick explained. And with the software, we have a Cloud9 website server, which that runs the website and also helps manage all of the data. And then we also use a MySQL hosting service to host our database. And then from that, everything was connected to create the system.
So this is just one of the screenshots of the website. As you can see, this is one of the tabs that you can view. This is just the all items view, where you can view all the items all at once. And in the top right, there's actually a search bar with filters, so you can search for assets based on different criteria. And this is the geomap. This just shows just 4 different criterion based on location. So you can view, for example, what items have passed through the door, what's been placed on rack 1, what's been placed on rack 2. And you can also view any items that haven't been read or erroneous.
So we had 2 main components for our system. One was the software and one was the hardware. And that's how we broke up our test plans and how we're testing our system. So for the hardware itself, we had the readers and the antennas. So the reader came with its own application, and we used that to test all of the tags and make sure they work the way we wanted to. So some of the test cases, as you can see, the door must be updated every second, or the door must use TCP/IP and other test criteria. We use that to help our testing and to make sure it passed and failed, and fill the requirements based on what was given from the customer requirements.
So for the other engineering requirements and for test plans for the user interface and database, the requirements were rather lenient for the visual part of the website. It was more focus on the functionality. We attempted to use an Agile Scrum method to handle like the development of the database and the website. That wasn't so successful, but we quickly transitioned to sort of a waterfall method, and that actually worked best. And these are just some of more of our test plans.
And then once we completed the test plans, we made a table that showed the requirement numbers that were fulfilled and the test plans that they corresponded to. We were fortunate enough that all of our test plans passed and they fulfilled, I believe, almost all of our requirements. And I think the last one was the tag that had been changed. So we initially failed, we talked about it, and then it passed our test once we changed the requirement.
And just to add to that, in addition, there were 3 main objective requirements that weren't necessarily required to get done in this project timeframe, which were email and text message notifications and a log file system, which were completed, and that's shown in test result 4.3.
So the plan and schedule was, I would say as a team it was difficult to figure out at first because as a college team it's typical that you just kind of work on it until it's done. So actually applying a schedule and sticking to it and adhering to it and making revisions to it was a really fruitful learning process because we really figured out how to actually divide our time into useful slots. So we have a full plan and schedule in our actual report, but we split it up into just the basics here. So we have on the first column, we have the planned hours, the actual hours after that, and then the time period. So just to break that up, the first 2 columns are how many hours per week we worked on that section, and then the time period is for how long we worked on it. So for the first one, for example, we developed the website. We planned 14 hours between February and March. It only took 13 hours, which is good. And actually, if you look down the rows, we were actually very accurate, if not a little generous, with the amount of hours we assumed it would take to develop these products. And I think that was really good for us to give us a generous timeline because we were told in our classes that a lot of people greatly overestimate what they can do in an hour. So we decided to take that to heart, and we took what we thought it would take, and we effectively doubled it or even tripled it in some cases. And we came really close to those numbers, which just goes to show that no matter how good you think you are, you gotta give yourself some buffer time. And then, so just as an overall summary, the lessons learned is we really learned the importance of planning ahead, risk assessment. Risk assessment is something I learned in my internship at General Dynamics, and I had never really seen that before, especially in like school projects, even science fairs, learning in class, things like that. You never see, we never had seen people saying, we think this could go wrong, let's change this to prevent that from happening if it ever could. And that was really useful for me, for personal experience, and to apply to our project here, because things like the reader, the choice, not having support on the reader would have stopped the project completely. And that was something that was vital to the success of this project. Now we also figured out how to increase the detail of our test plans. Having something written that anybody could pass or fail it and perform the test is really important, not only for the real world, but for development in the first place. And it really, I think, was one of the vital steps to us being able to be productive in this project, especially with other classes going on. We also learned how to develop checkpoints to make sure that we actually had provable progress at a time, because we had, in separate projects, the 3 of us had in previous semesters had projects that looked like they were going really well until the very last day, and all of a sudden they fell flat on their face, and we had nothing to show, even though we had put all this work into it. So designing these checkpoints so we can do this, we can show this, especially from a company standpoint, being able to go to a manager or even a supervisor, even like the head of your department and say, it wasn't successful, but we've done this, this, and this, and we can prove it, is so much more important, I feel like, than even having a successful project in the first place. So moving forward, if we were to actually develop this into a real product to be used in the field, a lot of the foundation that we built for this project is really solid. We would have built upon that. So for example, we would have taken the laptop functionality, because the laptop controls the reader at this moment. What we would have done is the reader that we have now has the capability to load on .jar files, which is effectively a compressed Java project. So we could automate and we could automate the reader to be able to do all those commands at the intervals it's set by themselves with the same project. So theoretically, we could buy 10, 20, 30 as a company readers and throw the same code on that in different parts of the world, point them all in the same database, and then have access to all these locations from anywhere in the world as long as it's within the set security. Beyond that, I think just being able to make the project more efficient would be what we would take forward. Like the hosting service, we used Cloud9. Cloud9 in the middle of our project was bought by Amazon, surprise, surprise. So we would definitely have switched over to Amazon if we were to continue this project, as well as individualize the notifications, because they're just broad notifications for them. We'd actually create users and like settings for these users if we were to make it an actual marketable product. So I think next we're going to do a short demo. If you guys have any questions, feel free to ask. In the middle, we'll take them. And if you guys want to follow along at home, if you guys take up your phone or laptop, if you have one, you can actually go to this website link and look at our website in real time with us. So what we're going to do is, you know, set up. Okay, cool. So what we're going to do is we're going to show the demonstration of the reader working, and then we're going to run our scripts manually just to show you that it works, and we're going to look at the website and see the changes. So if you want to show the RFID program, so you can show your tab. Awesome. So the RFID company has this software for development that makes it really easy to debug and to use this software. So these 6 boxes right now, they are actually the tags that are found by the readers. And if you see the @ numbers at the bottom right corner of each box, it shows the antenna that it's being read from. So 0 would be the door right here. 1 is going to be one of these racks. 1 is this rack, and then 2 is going to be this rack. So if I take an object out, you can see that first one, the bar goes down, and that's just persistence. It has no longer read it, it's just keeping it on the screen for a persistent time. But if I take this and put it right down here, it shows right back up. See it right at rack 2, the top. So we can do this with anything. We can take a box out, right? And this would be like, let's say you're in the lab and you have, and this is your product, right? And you want to authorize the movement of this product from this to that. And you would message the person using the equipment and say, okay, I allow you as the custodian to move this from here to here. And you can actually verify that from your desk, from if you're on travel or anywhere. Once the person moves it, you can either get an alert on your phone through email or text, and you can see it show back up. And this is just proving that you can actually get a really high level of accuracy in these. And I can even just show you the door just to kind of use an example. So if I walk through, you're actually going to see, there it is, yeah, see the 0 at the top, right there. And the cool thing about these tags is that, like I said, they're passive, and these are metal-mounted tags, meaning that they are designed to be put on metal, because most server devices are made of metal. So having something that actually performs in this specific environment is very important. And the nice thing is they're adhesive. And another requirement we had was that they had to have barcodes. So this tag was able to pass all those requirements because it could fit on metal adhesively, be able to take off without damaging the device, and also have a barcode to use scanners for other types of asset management things. Now, if we could turn on the website, we can show how it translates into the database and then the website. Yes, question?
And if your ID card, you probably have to wear all the time,
Yeah.
also is RFID enhanced.
Yep.
When you walk through the doorway with that package, you would say, Alex took something home.
Theoretically, it could, yes. The way we designed the database was to filter out tags that it didn't know. So let's say like a lot of people with Android phones, they have NFC in their home. Like they have like settings, they tap their phone like a sticker on their bedstand, and it turns off like their Bluetooth and their Wi-Fi and things like that. So if there's tags in their pocket and they walk through, it won't show those. Although if we were to add those users, like those company tags like you spoke about, into the database ahead of time, we could definitely do that. So that is definitely a capability we could add on to, which is very nice.
So right now what we're doing is we're telnetting into the reader and we're updating our database. And then from the database, it's going to, with the Java file we were talking about, it's going to update the website and you can see it update. So that we already got the data. Now if you reload the website, so now you can see that we have certain items in rack 2 and we have certain items in rack 1. And that's all from what's live here right now. And then if we were to add one, you can add one to our rack. We can run it again. It's doing the same thing. It's talking to the reader. The reader is updating the tags that are being there, and then that's being sent to our database. And then from the database, the website's being updated. So that takes a second. Once that's done, we reload our page. We should see another item in rack 1. Now we have another item in rack 1, and that was updated in about, we would say, 30 seconds or so.
And so now Nick is going to show the search functionality, which allows us to be a tool to be used when there's a lot of tags we can't obviously just scroll through all. This is the capability we have to filter and search and kind of look for certain tags we like. And the nice thing about this table is that it has information about tags that the IT of the company would input ahead of time. So like the custodian, the serial number, any other information like the ID if it has an ID, or even special parameters or like a name. Like let's say it's a dark fraud or something like that, some sort of Cisco router or anything like that. You can put that in so you know that serial number 6523 is a Cisco router, which would be useful. So Nick, if you want to talk about this for a little bit.
So for each criterion, for each item, you can use any of the columns for the database as filters. So if I want to search by RFID number, I type the article. I won't do that because it's pretty long. If I want to search by serial number, I can search verbatim what I'm looking for, and it'll appear in my results automatically. You don't have to type in search and then wait for the results to pop up. And additionally, this is the GeoMap Live. So right now we have some items that we're not using. Sorry. There are items that we're not using, and they show up in the not read or error section. And we also have door in rack 1 and rack 2. Another functionality we added to the system was the refresh functionality that's done on its own. That's actually just a header that's set dynamically by PHP. And you can set it for any number of seconds. You can set it for a day, every 30 seconds. It doesn't matter. It can be customized for any system, for any company. Going back to the email functionality, at first, during the middle of the semester, I couldn't get the data to be sent over an email, but I went to the here doc pages for PHP, and I was able to assign the data to a variable and send it over an email. So now you can see the table both on the email and the website.
We also have SMS functionality as well, which is actually much simpler than we thought. We thought we were not going to be able to get it, but we were going to try if we had time. It turns out if you email a phone number at some server name, which is carrier dependent, you can send emails to phone numbers and they send us text messages, which is fascinating. And we were able to get that running in. Like we actually found out we could do that over like some article that we found and had it working within 5 minutes of reading that article. So that functionality, which was an objective, it wasn't a necessity, but it was a nice perk that we were asked. We were able to actually fulfill, which is great. And so this website, the most important part of this website is the ease of access of information, of location and information of these devices in general. And one of the requirements we have, which is very important, especially for government assets, is that there's a government website associated with these items. and we were asked to provide a link in the tables that allows us to go to that website for that specific item. Now, here at UMass, especially as non-full-time employees of GE, we weren't allowed access to this website, but we just wanted to show that we have a link. It is a text message being shown. We have a link that we put in under the government tag, and we didn't have the government site like we said, so we figured we'd put something else in, just kind of, show you guys how it works.
Sorry.
Sorry.
You can email it to a text.
Yes, yeah, you can.
Text to an email.
Yep. So yeah, we didn't have access to the government site, so we put this instead. So yeah, and that's our project.